Hello, this is Miss McKinney, and I just wanted to screencast the directions so that you can hear them again. And these are the math directions for the cell project that math and science are doing together for 2018. If you're listening a different year, then we might just have a different due date. So I wanted to start out showing you Scale Ella. You're welcome to look it up on YouTube. It's just Math Snacks Scale Ella. You can watch that again to review scale factor if that works for you. Because you need to remember that scale factor is just a number multiplied to change the size. So you're going to be figuring out your own scale factor for your cell project, and you will use the same scale factor for the entire project. The prokaryotic and the eukaryotic cells will have the same scale factor. We also need to take a look at millimeters. So if you get out your ruler and look at the centimeter side, the numbers are centimeters. These little bitty marks up here are the millimeters. So hopefully you have a ruler that's a little clearer than my picture here. And you can count all these little bitty marks all the way to here. This one's 0. And if you count to 1 centimeter, you will find that there are 10 millimeters in a centimeter. Then we can find out how many there are in an inch. So say, look at 1 inch, go across and count to here. And between 0 and here, you'll find there are 25 millimeters in 1 inch. Then if you look at your whole foot-long ruler, it's a little over 30 centimeters. And since there's 10 millimeters in each centimeter, and then there's a few extra, a foot is 305 millimeters. For your project, you're going to be calculating how big different cell parts are, and you're going to be measuring them in millimeters. And when your teachers grade your project, we will be getting out a ruler and looking to see how many millimeters each item is. So it has to be super accurate, and you're using all these little bitty lines and you know how to count them accurately. So if you were in class, you got the cell project paper. Make sure you put your first and last name on it. The class period you have math, and the class period you have science. I'm going to go over this quickly, then we'll come back and do some in more detail. So you have your due date. The objective of the project is to enlarge the dimensions of a prokaryotic and eukaryotic cell to scale. That means you're going to have to think about what number will work best to be your scale factor. And we'll come back and do these together in just a second. You have a checklist. A lot of students come to me and go, I don't know what to do next. Well, that's what this checklist is for. You're checking off things as you do them. So the first thing you're going to do is choose a scale factor, and that'll be helpful with above. Then we have this section, which is for the prokaryotic cell. You're going to enlarge each dimension, showing your math on the table. You're going to draw the prokaryotic cell using a measure and the sizes of the organelle and cell parts to make sure you're keeping it to scale. You're going to label the parts. You're going to write prokaryotic cell above it, and you're going to color it neatly using colored pencils. Then, this next section is about the eukaryotic cell. You're going to enlarge the cell dimension, showing your math work on the table. You complete the drawing of the eukaryotic cell using a ruler to measure the sizes of the organelles and the cell parts and make sure you're keeping it to scale. Label all the parts. At the top of it, write eukaryotic cell in the center. And then you're going to color it neatly using colored pencils. When you're done drawing the 2 cells, labeling them, coloring them, all that good stuff, you're going to do a math reflection. And the math reflection is going to be right here. You're going to respond to the prompts. You can handwrite it or type it, and it needs to be a total of 10 to 15 sentences. Then Ms. Kiki will tell you about a science reflection that you're going to do for that part of our project. So the math reflection is going to be graded for communication. One of our math objectives is that we need to be able to communicate about the math that we do. And this is a great project for that. You're going to show your work with numbers. You're going to measure, you're going to draw, and then you're going to write about it. So there's a lot of communication going on. And in the reflection, I'm not really looking for your feelings on the project. I'm looking for you to discuss these bullet points. So you need to discuss why we needed to enlarge the cell dimensions by a scale factor to be able to draw it. You're going to need to discuss why you chose your scale factor for this project, why that's the one that you needed. Discuss in detail the math steps, showing your work for how the enlargement process works by multiplying by that scale factor, and make connections to that base 10 number system. You should understand the base 10 number system and how it works with dippy-doos. You're going to discuss the process of how you drew your two cells, and then discuss any concluding thoughts on the activity, such as what did you learn or what did you take from this activity. Then you have some charts. You're going to choose that one scale factor, and you're going to put it in every one of these boxes. Not just for the prokaryotic cell, but also on the next page for the eukaryotic cell, the same scale factor. Then when you're ready and you have that scale factor, you're going to multiply the dimension times the scale factor, showing your work right here, and write the answer here. The new dimension will still be in millimeters, so make sure you write mm. All right, so you're going to multiply this dimension by your scale factor, showing the work, and writing the answer, which will be in millimeters. Then we have a couple of pictures of the prokaryotic cell and the eukaryotic cell. And here's the trick. So, little known fact, Miss McKinney actually has a master's degree in biology. You can Google prokaryotic cell. This is what shows up. It's in all the textbooks all the way through the master's level and everything. And yet, they're wrong. It's your job to correct it. So, this is what the parts look like and what these parts look like. But the scale is wrong. They've kind of enlarged it to show detail. But it's your job to draw it on the correct scale and still show us a little bit about how those parts look so that we can see what's really going on with these cells. So you're using these pictures to see how many parts, where they're located, and what they look like, but not what size they are. After that, in your packet, it shows you how we're going to be grading it. And like I mentioned, for math, it's going to be on communication, mainly on that math reflection. So make sure that you've done the math correctly, shown your work. Make sure it's clear enough to read. You've drawn and measured accurately, and then you've written your reflection based on all of these. Then we're going to come back up to the top. And, of course, you've already put your name and everything up here. We're going to take a look at the deadline. And it is the beginning of your science class period, so whatever you wrote here, you're also going to write here. And then you're going to turn it in with Miss Kiki, so write Kiki here. And then we'll talk about when it's going to be due. So if you have science on A day, it's due November 8th, 2018. If you have science on B day, it's due November 9th, 2018. So make sure you're putting that in this blank. Then you are going to choose a type of paper to have it, or you can choose three-dimensional. So I have some large construction paper, or you can get some, and it is 300 millimeters at its narrowest point. A regular poster board is 500 millimeters, and I have big poster butcher paper that's 900 millimeters. And so you need to choose how big you want your cells, and that number is going to go right here where it says measurement of paper. If you want to do a three-dimensional project, you're welcome to do so with clay or craft items or styrofoam, whatever it is that your mind can handle. And then we can figure out how many millimeters your final project is going to be. You need to have a goal measurement. A eukaryotic cell is 0.5 millimeters. So write that right here, 0.5 millimeters. Then we need to calculate your scale factor. And that's going to go right here. So here's the trick. That 0.5 is half. So 0.5 of your scale factor equals your paper size. So write this formula in the blank spot right here in your packet. 0.5 times blank equals your goal size, however big you want to make it. And you need to think about what goes in here so that half of that number equals your finished size. And that will be your scale factor that you put right here. And there's no millimeters, it's just a scale factor. And you're going to put it in every one of these boxes. Every one of these boxes. After that, you're going to go through and you're going to multiply your dimension by the scale factor, showing your work right here. Write the answer here in millimeters. It will already be in millimeters. Just make sure you put mm afterwards. And when you're done with all those calculations, you're going to draw. So this is the eukaryotic cell. The whole thing is going to be whatever answer you have right here on your paper. And that is this big circle right here, the whole cell. Okay? And if you calculated correctly, it should basically cover most of your paper. If you need any further help, Miss McKinney has tutoring every morning at 7:40 a.m. I'm happy to help you with the project, but keep in mind it is a summative, so I can't tell you answers. I'm also here Wednesday and Thursday after school for 30 minutes. And if you really can't make it before and after school, you can come see me during advisory with some quick questions. So good luck on your project. You're going to do an awesome job. And I will look forward to seeing your beautiful pictures.